Nice to meet you all. And today I'll be talking about one of the cases that we have built for insurance. And we'll talk about the problem itself, initial state. We'll talk about the solution, and we'll talk specifically what are the key points of the solution. And then we'll talk about what are the benefits of it and how maybe you can use it. So to introduce myself, I'm heading Big Data and ML Grid Dynamics. I'm principal architect and responsible for sophisticated programs implementation. And today I'll be your speaker. All right, and before we'll start, quick question. How many of you have worked in insurance sector? Maybe you can raise your hands. Oh, I see many hands. All right, so this is a good case, and maybe you can share your experience after my talk. So let's talk and a little bit about it. So initial state, our customer was hosting on premises in the private data center. The data and ML platform that was built was quite legacy with a lot of complexities, permission issues, with a lot of special cases in the way how they were handled. As you can see, number of ML models were not that high, just about 30 models. And this was the key problem of the business. They wanted to scale drastically and have more than 100 models handling specific business cases, but the premises platform was pretty much limited, and that's why they were considering to have a replatforming program, build everything from scratch, and they were considering to go to the cloud. So to just outline the challenges, the primary challenge was very high cost of ownership and very long time to market. Any model which was developed on top of on-premises platform was kind of hard to test, to run any kind of user acceptance testing, and then release to production. And also, since the platform itself was built, actually, the implementation of the on-premises platform started back in 2015. The platform was outdated, and it was very hard to onboard any new capabilities on top of the platform. And obviously, the technical stack was legacy one, and also was one of the reasons of long time to market. And many of you know that insurance sector is kind of a place where you have a lot of permissions to be configured with special treatment of PyData, with very strict security rules, the way how the data is being processed in the company. Same was here. Security compliance was very strict, and the client was very interested if they are migrating to the cloud, how the security compliance may stay as is, but actually the number of limitations or easiness of engineering to work with the platform will be much higher than it was on top of the on-premise platform. So having all these key points as a baseline, we started our platform implementation in terms of the architecturing the platform. And we were discussing a lot of cases how we can go either cloud native or cloud agnostic. And maybe you can help me with understanding how many of you have implemented cloud agnostic solutions in the clouds. And the rest, I guess, have implemented cloud native, right? I think so. All right, so, and this is the case. If you would like to be cloud agnostic, you have to invest extra efforts just to build application layer or platform and application layer, which is relatively easy to migrate from one cloud provider to another cloud provider. But in case of our customer, the speed of development was a key point. That's why we went mostly cloud native with some specific services which are cloud agnostic. And typically, the way how we are dealing with our customers, we give them a choice whether they would like to be cloud native or cloud agnostic. And I would say 2 out of 3 customers are definitely interested to be cloud native. So the legacy architecture was not very sophisticated. There are cases when either insurance agent or customer itself works with the infrastructure, with the services itself. And the infrastructure was quite linear in terms of several models deployed on premises under load balancer and serving 2 types of requests. Either insurance agent is calculating insurance price and issues insurance to the customer, or the customer itself can do it, for instance, via mobile phone. There were a lot of challenges with this architecture, just because the way how models were stored in repository, tested on the environment, and then released to production was fully manual operation. And this was the primary challenge why time to market was significantly high, and why actually development teams have to wait before all the manual operations are applied before the model runs in production. And the customer was very interested to consider another solution where these all steps can be automated. Actually, the challenges itself, like deployment of new model or issuing a hardware in on-premises cluster before deploying a new model, were pretty manual operations. So this is a kind of Jira request to issue a new hardware, which will be dedicated specifically to the new business functionality. Once the hardware is there in the data center, you can start releasing to production. And these are obvious manual operations that cannot be avoided and can't be automated in on-premise cluster. That's why actually the entire CI/CD was not fully automated, and that's why actually cloud implementation should be not just lift and shift, but full rework from the scratch, where we are delivering fully automated platform and ability to manage model lifecycle from the code, but not manually. So these are technical challenges, and before talking about what was the solution specifically, I would like to talk a little bit about several key points of the solution which were addressed in the cloud architecture. There is such kind of thing like feature development. In different industries, feature development is pretty much different. But in each sector, there is a well-defined a well-defined process how features may look like, how they are calculated, and what data is used to create features. And I'll bring a couple of examples. Let's say you would like to issue a driver insurance, vehicle insurance, sorry. The driver profile, which is used to calculate the insurance price with all specific fields like number of car incidents, the age of the driver, what is the experience. These are pretty well-defined features, and they are not changing from year to year. Obviously, there might be some kind of new insights and some slight data changes, but overall, feature development in insurance is well-defined. This is number one. Second, feature development itself is the way may be done by data engineering team, may done by data science team, and also in production there should be a way how features are created, how the serving is working on top of the features. So model development and production serving both should have same way of creating features. And here in insurance sector, we were aiming to create one unified way of creating features so that it can be reused for data engineering teams, it can be reused in data science teams, and obviously it will be the same than models running in production. And this kind of reusable concept is a core thing of the platform, since it helps to drastically reduce efforts to release model to production. And maybe I can bring an example on top of this architecture of the cloud platform. So let's assume that you would like to develop a new model which is calculating cost of the marine insurance. You have identified all the features that you need, and you have created it for your testing purposes. Once you have created these features, they are obviously available in development environment, and you have completed your model development. Now you would like to move it to user acceptance testing environment. And you need somehow these features to be present also in user acceptance environment, but you don't want these features to be copied manually, or you don't want this process to be manual. So you may define these features as just the Python functions. Then you commit these Python functions, and once the code is there, you are creating a package which exactly represents your feature. So here it is. This is your feature. It will be used for development purposes. It will be used in production. And we have built a custom application, which is actually a catalog of the features. You can search there, you can see offer, you can see what versions of the feature is available. Now, let's assume that we are going to production and we need to create these features in production environment. We might do it in batch manner, or maybe we can do it in streaming manner if required. Since it's just a Python function, it can be reused in any environment and can create features in production in automated manner. Now we have created these features, put it in our feature store, and let's assume that we are running we just released our model to production, running it there, and see that accidentally we have a new customer for which we don't have specific features. That's absolutely fine. We can calculate on the fly, just using a model which is running on top of SageMaker. We'll fetch base data set, apply this function from the repository, and calculate needed features on the fly. It will take around half of the second to do it end-to-end, but still fine, and still from performance perspective, the client won't see any delays during the calculations. I mean, there won't be significant delays on the, in the mobile or on the website. So this is how it works, and this is how it helps to unify data pipeline development, feature development, and serving layer. And a few words about architecture itself. So it was running, it's actually running in AWS. Heavy data computations are running on top of EMR. These are essentially PySpark jobs running on top of it. Almost all cases doesn't require streaming data processing, since data preparation, feature preparation is mostly batch in its manner. And if you imagine like typical life cycle of customers in insurance sector, you buy an insurance typically once a year for your car or household, and your next visit to the insurance company will be in a year. That's why actually the time which, the way how insurance companies are calculating lifetime value for the customers significantly high. They are taking the data for the last several years to see what is churn score rate, and optimizes models based on top of this data. And serving, let's maybe specifically talk about serving layer. The serving layer actually is implemented on top of SageMaker. All models are running on top of SageMaker and exposing REST interface. Number of models can be scaled, and it's not actually limited. So we were able to scale drastically number of models from the point when it was on premises, and then all the operations migrated to production. So actually, the key point here is that this environment is pretty much isolated and doesn't require specific things to be available outside of the environment. That's why if a site department wants to provision yet another environment, it's pretty much easy, fully automated, and can be done from scratch. And actually, what I wanted to like highlight about the solution itself, key points, and business benefits that this solution has brought. So first of all, the simplification of the solution helped to start developing more ML models, start to like onboard new business use cases, which were significantly costly to onboard using on-premises platform. Model development efforts itself were reduced drastically. So you don't need to do many data preparations on your own. You don't need to search specific features or create them for your testing purposes. Many of them already available, and you can just use it. Also, the platform itself helped to separate the cost across different departments. So if you would like to run your own setup of models, it can be easily run using your AWS account, and this can be separated across different departments. And scaling, yeah, obviously it's there. And talking about technical benefits, this migration actually helped to solve technical debt that was there for last 10 years of on-premise platform development. Since everything was implemented pretty much from scratch, it helped to take new approaches new technologies, consider how you would like to run it in the cloud, and build everything from scratch. Also, previously in on-premises platform, the different teams might use absolutely different approaches, absolutely different technical stack, and that was very high and it was introducing high operational costs supporting it in production. And this solution helped to unify the approach, helped to unify technical stack, helped to reduce support team, which is supporting all the production applications. And finally, talking about development environments, this is a thing that typically many of our customers are not taking seriously, but this is a key point of like engineering comfort developing anything. And we have delivered development environments which are separated from production environment. Data from production environment is obfuscated and can be used on development environment that easily. So this is still production data, which is exactly distributed as a production data, has exactly the same features as production data, but name, last name, email are obfuscated. That's why you simply cannot use this personal data anywhere. But still, you can develop all the models, and the data exactly mimics what you have in real life. And development environment has a lot of capabilities. For instance, you can run specific services in AWS, or you can tune types of SageMaker instances that you are required to run ML models. And it greatly helps not to do it through a ticket to IT service, but it helps you to do it manually and just reduce time required to develop a model. So this development environment is very friendly, and all the development teams warmly migrated to the cloud development platform and started using it extensively in terms of new features that cloud can provide. So these are main achievements of the platform development, and we are slightly approaching to Q&A session, and I'm here to help you.
Hello.
Yeah.
I'm here.
Yeah.
Thank you for the presentation. I'm interested, what kind of problems have you solved in insurance domain using ML models, like the most interesting ones?
So the way how the program was taking 2 years. First one is to implement the platform, and second to implement new capabilities on top of the platform. And second year program was focused on building personalized recommendations for specific segments of audience of the insurance company. So it was more targeted recommendations and improved churn predictions with was identifying whether customer is about to leave the company.
Okay, thank you.
Yep. Yep.
I would like to know
Maybe you can take a microphone. Yeah.
I would like to want.
No worries.
I want to know how did you implement the versioning and tracking of ML models? Was it MLflow or other technology?
Yeah, great question. So typically during the development, you need somehow to track the experiments, track the models, and tie together experiments and model versions. So in our case, I did not mention specifically on the architecture. Yes, it was MLflow, which we used to track model version and experiments, which was running for this specific model, and also features that were used for these experiments. That's why it was tracking of model, feature, and results of this experiment.
Okay, thank you.
Yeah, hey, I guess last piece that I did not understand is the actual data science workflow for the data scientists on the team. So they probably use some notebook environment. And if the features are prepared and stored in some catalog and like stored, the definition stored as P packages, how does that work?
Yeah, great question. So for the development purposes, again, same SageMaker was used. And SageMaker is providing Jupyter notebooks. Since you have a catalog of all features, you have a catalog of Python packages applied with, to these features. You can use either these features, already created features, or you can use this information just to implement your own on top of existing features. For instance, if you are creating driver feature, which is like kind of general information about driver, but then you would like to subtract specific features about driver and use it, for instance, for the model which recommends specific, I would say, for the driver insurance recommends different types of insurance for the vehicle. This might be built on top of existing feature set by implementing your own feature set. And all happens in SageMaker, just using existing information, implementing it in SageMaker. Then once the model is implemented in SageMaker, it goes to, it passes a kind of refactoring to be running as a Python executable. Then this Python executable wraps into web service that can be run on top of SageMaker. And actually, this is it. It can be running in production.
Yeah. Yeah. First of all, thank you for the talk. And I have a question concerning the features that are packed in packages. How you run them? Do you trigger like 200 like lambdas and process them in the lambdas which are written to the feature storage, etc., or like how it's organized? I mean, that maybe I missed.
Yeah. This is a great question. Sorry. Yes, I missed it in my talk. Typically, the pipeline of features which apply on the base data set and create features is not that high. So about 10, like between 5 and 15 features. And they are, this pipeline is implemented in PySpark workflow. It might be a workflow which consists of, this workflow is orchestrated by Airflow. And it might be several steps of different steps in the Airflow workflow. It might be one PySpark job which creates target features. So answering your question, it's either one Spark job or several Spark jobs orchestrated by Airflow. Thank you. Thank you.